given to you later on. Okay, example of uniform series involving P over A. Right, we have a chemical engineer believes that by modifying the structure of a certain water treatment polymer, this company would earn an extra 5,000 per year at an interest rate of 10,000 per year. Determine how much could the company afford to spend now to just break even over a 5-year project period. So from this equation, you want to draw a cash flow diagram where you need to find the value of P, okay, and you have a consecutive payment for the next 5 years, n equals to 5, okay, even consecutive payment of $5,000 per year. So what is the value of P at the beginning of the project? Okay, so P given equals to 5,000 times P over A, 10%, n equals to 5, and equals to 5,000 times the factor 3.7908. Okay, at this stage, I know you'll be having a lot of questions. Where do we get this value? Okay, so right, let me show you how. What you can do, you can easily go to website. Okay, what you want is factor table. Compound interest table. Okay, this is the table that I've been wanting to show you actually. So you can have this. Okay, what do we have here? So in our question, okay, what do we have? We have P over A, 10%, n equals to 5. So our I is 10, n equals to 5, okay. I is 10, n equals to 5, we need P over A. So we go back to the table, right? So we go back to the table, we want, this is 1/4%. What do you want? We want I equals to 10%. So we scroll down to 10%. Okay, a bit more. Right, now we come to 10%, n equals to 5, right? Okay, n equals to 5, and n equals to 5, we're looking for P over A, right? P over A. So over here, for n equals to 5, P over A is 3.7. Can you see that? 3.791. Is it the same thing? 3.791? 3.7908. So it's pretty close, okay? It's just a matter of decimal values. It's still pretty close. Okay, that's how easy we find the value of factor. So you can simplify your calculation using a factor notation instead of lengthy equation, like for example if you use these, because the lengthier the equations, more mistakes can be done while you're calculating. Okay, but some people are really happy using these. Go on. If you want to go for a faster, shorter way, you can also use the factor table. Okay, combined factor table. Okay, now we should move on to uniform series involving F over A and A over F. So what is F and A? F is future value, A is series. Okay, so So how do you use this? The cash flow occurs in consecutive interest periods. Okay, it has to be consecutive. All right. And the last cash flow occurs in the same period as F. Okay, what's the difference? If you solve for P, okay, if you solve for P and A, the cash flow amount is the same in each interest period. If you solve for F, okay, the last cash flow occurs in the same period as F. Okay, what does it mean? Okay, F takes place in the same period of the last A. Okay, as compared to P is one period ahead of value A. You can see that? The first value, because we only start P at 0. We never start P at number 1. Okay, that's what it means, alright? Okay, be alert about these differences. So how do we solve this? Okay, example, uniform series involving F of A. An industrial engineer made a modification to a chip manufacturing process that will save her company $10,000 per year. At an interest rate of 8% per year, how much will the saving amount to in 7 years? Okay, so we will use over here, okay, the table. So we want to find F. F equals to $10,000. F of 8%, 7. Okay, 1, 2, 3, 4, 5, 6, 7. So it's straightforward, you get the answer, which is C. Okay, all right. So factors values for untabulated I or N. Okay, there are 3 ways to find factor values for untabulated I or N values. First, you can use formula. You can use spreadsheet function with corresponding P, F, and A value set to 1 and linearly interpolate in interest tables. Okay, you can find in some of the equations, some of the questions we will give you in your tutorial, in your examination or your midterm, we would probably ask you to do some interpolation. Okay, now we should move on. So for example, for untabulated I, determine the value for FP 8.3%, 10%. What does it mean by untabulated? Meaning 8.3%, you can't find 8.3% in this compound interest table. But what you can find is 9% and 8% interest rate. So when we have something in decimals, 8.3%, so we will follow this method to find the value in between of 8% and 9% from the table. So what we should do, from the equation, F equals to 1 plus 0.83 to the power of 10 equals to 2.2197. Okay, this is how we write in spreadsheet in Excel. Okay, spreadsheet Excel. Right, they are the same thing basically. This is just the formula, standard formula, and this is the one if you want to solve the using Excel. So we should interpolate. Okay, from this interpolation, x equals to 2.1589 plus in bracket 8.3 minus 8 over 9 minus 8.0. Okay, in bracket times in bracket 2.3674 minus 2.1589 in bracket. So x is 2.215. Is it correct? It says here absolute error. Okay, 2.215 minus 2.215 197. Okay. Okay, from interpolation, you may get some absolute error. Okay. But when you have untabulated I, you can use both ways. However, there will be some discrepancies. Discrepancy, meaning minor differences, but however still usable for solving this equation. Okay, so arithmetic gradient. What is arithmetic gradient? Arithmetic gradients are gradients that change by the same amount each period. Okay, the cash flow diagram for PG, that's the notation PG, of an arithmetic gradient is PG facing upwards, okay, and the G's must face downwards. Okay. G starts between period 1 and 2. So you have to be aware of these, that if you use PG, okay, G always start at n equals to 2, not at 1. Okay, this is because cash flow in year 1 is usually not equal to G and is handled separately as a base amount. Okay, this will be shown in the next slide. Okay, note that PG is located 2 periods ahead of the first change, that is equal to G. Okay, PG must be 2 periods ahead to the left, okay, of the first G. Must be 2 period, okay. That's the terms and condition if you want to calculate arithmetic gradient. So in a typical arithmetic gradient, you have PT. What is PT? PT is P total, right? You have the timeline here. You have the first year, second year, third year, fourth year, and fifth year. Okay, this diagram, okay, this base amount plus this gradient, okay, this diagram is equals to, okay, this base amount. What is the base amount? 400. 400 is the base amount, where 400 is the A, if you go what I mean. And the G value starts at number 2, where it increases by $50 each year after year 2. Okay, so how do we write this? We have 2 portions. P total equals to PA, which is this, plus PG, P gradient, which is this. Okay, so arithmetic gradient can be converted to equivalent A value using G in bracket A over G IN. So you can have an equivalent diagram like this. And the general equation when base amount is involved is the base amount plus G A over G IN. So equivalent A value is the base amount. You got to remember that when you do arithmetic gradient problems later on. Okay, now we move. How do we solve arithmetic gradient equations? The present worth of $4,000 in year 1 and the amounts increasing by $30 per year through year 5 at an interest rate of 12% per year is closest to, right? How do you solve this? Okay, in the cash flow diagram, okay, you want to find the P total. The present worth of $4,000 in year 1. Okay, so the 400 is the base amount, and the G is actually $30, isn't it? And it keep increasing after year after year 2 until 5. So we have 400, okay, times P over A, 12% interest for 5 years, plus 30 times P over G, okay, 12% and 5. And you put everything in the equation and you get the answer. Okay, the cash flow could also be converted into an A value as follows. Okay, A equals to 400 plus, okay, 30 times A over G, 12%, 5, 400 plus 30 times 1.7746, and you get that A equals to 453.24. Okay, what does this A means? This is the average A, okay, equals to 453.24 when you sum everything up and you put everything in uniform payments. That's what it means. Okay, so geometric gradient, if you proceed, is the gradient change by same percentage. Okay, the changes in arithmetic, okay, you got to know the change by the same amount. But if you go to geometric, it is the change by the same percentage. So thus, there's no tables for geometric factors. We need to use this equation. Okay, if G equals to I, PG equals to AN over 1 plus I. Okay, this is how we write the present worth value if you want to use geometric gradients. Okay, example is over here. Find the present worth of $1,000 in year 1 and amounts increasing by 7%. Okay, the amount increased by percentage. So that tells it's geometric gradient. Per year through year 10, use an interest rate of 12% per year. So the solution is that you must draw a cash flow diagram, finding PG with the first year 1,000 increases by another 7%. On the second year, on the third year, increases for another 7% from the second year, and in n equals to 4, it increases another 7% from the third year. So to solve this problem, you find PG equals to 1,000 in bracket times 1 minus in bracket 1 plus 0.07 over 1 plus 0.12 to the power of 10 in bracket divide by 0.12 minus 0.7, and you should get this answer. So for you to find A, you just multiply PG with AP 12% for n equals to 10. So right. Okay, now we move on to unknown interest rate. Unknown interest rate problem involves solving for I given n and 2 other values. Okay, for example, a contractor purchased equipment $60,000 which provided income of $16,000 per year for 10 years. The annual rate of return of the investment was closest to how much percentage? So you put $60,000, okay, API percent and 10 equals to 16,000. So the values you could get is 0.2667. From AP column at n equals to 10, okay, I is between 22 to 24%. So in the answers given to you, so you can give a good guess that the interest is about approximately 23%. You are also given unknown recovery period N, okay? Right, you can have this equation as well. You can basically read it up later. And here we go. We have covered everything, okay, for chapter number 2. First, we have calculated P over A and A over P. Okay, we have calculated F over A and A over F factors. And we have been able to find untabulated factor values. And the best way is to use formula of spreadsheet, okay. For arithmetic gradient G starts from period 1 and 2. For arithmetic gradient having two parts, base amount year 1 and gradient amount. For geometric gradients, the gradient G starts between period 1 and 2. In geometric gradient A1 is the amount in period number 1. And lastly, for you to be able to find unknown I, and you need to set up equation involving all terms and solve for I or N. Okay, today I'd like to end chapter number 2 lesson for today, and I wish you all the best.